So we are continuing our exploration of MCQs P1, and this one is for magnetism topic. So question number one, four plotting compasses are placed near a bar magnet. Where do you see the compass orientation like this? It will be point C. Remember, the magnetic field lines are coming out from north going to south. So is going like this, and this will be something like here. So it's going to be C. Question number two. So if it picks N pole and the same end also picks the S pole, that means it is iron. And why it is picking both poles and why it is S pole when, well, why it is picking both poles? Because it is iron, so iron is attracted by magnet. Now, what pole will be at position P? Well, when this metal rod is brought close to a permanent magnet, it is magnetized, so this pole becomes S pole. And although it's not asked, but in this position, when it is the same rod brought close to the other side, this becomes N pole. It's a temporary magnet, so it changes poles as per the requirement, as per the need of the hour. Number three, we have a metal ring and we have some equipment, magnetic field lines, and this is screening. So screening means when we place anything inside this metal ring, the magnetic field will not go through the metal ring. It will be absorbed by the metal ring, so nothing will happen to this equipment. No effect of the magnet will be coming here. So the metal ring is made up of iron, and the reason is the metal carries the field lines around the equipment. So the field lines coming like this will go like this, always, forever. Number four, so magnetic field strength, when the current is increased, the magnetic field will be where it will be increased. So it's a tricky question. People might tend to say, okay, it's going to increase here. No, this is already a very high, strong magnetic field here. What's going to happen is the magnetic field here, which is weak, will become stronger because of the current, because current will produce more stronger magnetic field. So K will increase and L will increase less than K and M will increase the least. That's the reason. Number five, suitable core material will be iron for making an electromagnet, because we want to demagnetize when we switch it off. Number six, iron can be picked, aluminium no, copper no, plastic no. Number seven, the material should be used to make the box is iron. Number eight, it's a steel that always produces, and should be placed in a DC current carrying coil. Number nine, so what happens if the two are brought together? The AND P and AND Q both attract X. Why? Because it always comes to rest with AND P pointing north, means it is a magnet, a permanent magnet. So XY, same material in no definition, that means it will be attracted by both ends of the permanent magnet. Let's see why B, C, and D are rejected. Is because we are repelling one side of Y, which is not possible because XY is not a magnet. Neither attracts. No, it's going to attract because it says here. And P repels. No, repelling is not an option because XY is not a magnet. Number 10. So if it stays magnet even after the current is switched off, it means it's a steel. All other materials, well, aluminium and copper do not become magnet. Soft iron becomes magnet, but it doesn't stay magnet after the switch is off. Number 11 is a magnet. It's a matchbox, and these are the clips. So once you place the metal sheet, the sheet is made from, well, it's not iron, it's not aluminium, it's copper. Why? Well, that's a very good question. Let's read the question. So it's the sheet of a metal between the magnet and the clip. So we're not bothering because we don't know. It can be copper or other aluminium, but it can't definitely be iron because if it is iron, it will still attract clips, stay attached. And sorry, it will not be picked up because all the magnetic lines will go in the iron shield, and it's gonna like suck all the magnetic field lines. It's not gonna pass it through to the paper clips. But if we place a copper sheet, why? When we place the iron sheet in place of Y, the sheet acts will attract, but sheet Y won't because of the reason that sheet Y is made of iron. Iron will take all the magnet inside it, and it will not allow magnetic field lines to go to the paper clips, due to which they can be attracted. Whereas in terms of the copper, it will allow the magnetic field lines go through it. It means the clips will still be attracted to the magnet. Number 12. So the compass arrow is always north, so it will only be attracted towards the south. Reject these two anyway. All three of them are rejected because this is the only choice. So we have the lines repelling each other, going away from each other. That means the both same poles. And look at the lines coming out from this side. So that's a north pole. Coming out from this side, that's a north pole as well. So C is the correct choice. Iron is used for this purpose, magnetic screening. There's the connector, and the current is going in. So at P, the field is stronger, so we choose P. It's not going to be stronger at Q, we reject Q. And then at P, if we place the right hand in the direction of the current, that means our thumb will be down, so our fingers will be curling in the clockwise direction. So we choose A. So we have a compass, current going through it. Again, we use the right hand, put thumb in the direction of the current downwards. That means the finger will be curling this way, and that's why the compass will point in this direction. C. Number 17. Well, at X, we have S pole because S pole will be attracted towards N pole. And that's why on the opposite side, we will have N pole. Number 18. So a non-magnetic material is copper, magnetic is iron, and a magnetized material can be compass. Why are we rejecting B? Because of the polythene, it can't be magnetized. Compass needle, it can be magnetized, but iron is non-magnetic. No, iron is magnetic. Iron is magnetic. That's why. Number 19, a bell circuit. What happens when battery B is disconnected? Very carefully look at the circuit. So we have an iron core that is attracting the iron armature. When this armature is attracted, the bell doesn't ring. But when we leave the switch, when we release the switch, switch is off, iron is demagnetized, this is released, and because of this releasing and inertia, it hits the gong. This gong then makes the bell sound. Sorry, this metal will complete the circuit. It's not going to bell, it's to complete the circuit. And this completion of the circuit means the bell will sound. There is no gong, sorry. So the bell rings when the armature falls, when the switch is opened, disconnected. Number 20, well, we use something that is easy to magnetize and demagnetize. 21, how the nail can be demagnetized. We use our knowledge from the book. We remove the nail from the coil when using an AC supply. Remember this. So a metal is steel, it is magnetized difficultly and demagnetized difficultly. Everything is wrong. Iron, it can be magnetized easily, but it can also be demagnetized easily. That's why we're rejecting B. A is wrong anyway. Iron is easy to magnetize. Number 23. How can we magnetize the steel bar? We demagnetize the steel bar. Well, we use an AC supply and we decrease the current in the circuit gradually, step by step. That's how we will demagnetize this. Number 24. Electric field lines between 2 points always coming out from a positive side, ending negative side. This one is from previous topic. Polythene is rubbed with a cloth duster, becomes negatively charged. When it becomes negatively charged, it means it gains electrons. So reject C and D. And if this polythene gains electron, that means the cloth has to lose electrons. So B. Number 26. Current changes when voltage across a fixed resistor is varied in this. It never changes this way and it doesn't stay steady. Number 27, all the arrangement. What happens when DC current passes through the coil? Well, only iron is magnetized because brass can't be magnetized. It is not a magnetic material. So current in the coil, both sides attract pins. Current is switched off. The table gives the result, the experiment. Number of paper clips checked when current in the coil 35, number of paper clips when current is switched off 0. And this is suitable for making circuit breaker because we don't want it to be stay magnetizing. This reject, we can't use this one. This one, it will still have two pins attracted. We can't use this one. Why we can't use first one? Because we want to magnetize it. This is only picking one pin. We want to pick the lot of pins. So 35 will be the lot of pins and 0 when it is disconnected. Number 29. So what does end P do when the switch is closed? When we close the switch, the AC supply magnetizes this. The iron nail is attached to this. So the iron nail will attract this armature and the P point will go up. So because this is an AC supply, let's reject the other options. So it doesn't go down. That's it. It goes down. No. It goes down and then returns. No. It goes up and then returns to original position. So why it's not D? Let's look at the thing again. So when circuit is closed, consider the AC supply. AC supply is something that increases and decreases. So to be honest, I think it should be delta because when the AC supply increases, no, it will still be D because the AC supply means we have a positive current and negative current. The only difference this will make is the alternating of the poles on this electromagnet. So when it is a positive current, there might be a north pole here. When it's a negative side of the current, there will be south pole. In both cases, the nail will be magnetized and it will attract this. So P will stay up. So the power lead is the only part in a videotape that doesn't rely on the magnetic operation. The driver motor uses magnetic head. The transformer, it does use magnetizing and inducing the EMF. And the videotape is actually a storage using magnetic material. 31. Nail becomes an induced magnet in A. Why? Because this is a magnet. This is not going to do anything. Same here, this is not going to do anything. In C, the iron is inside the coil and the switch is open. That's why it's not going to do anything. And it doesn't say anywhere that we're closing the switch. If we close the switch, then this iron will become a induced magnet. This this might also, but we're not closing the switch. And it clearly says here open switch. It's a loudspeaker. We need an alternating current. Why? Because we want the coil to change its poles to attract and repel north and south poles, move up and down, and produce the vibration. the vibration produces sound. So we should have an alternating current passing through it, and that is to make the coil vibrate. Number 33, consider point P. If we have a larger current, the field strength should increase at P, and if we use the current in the opposite direction, these lines will change direction. The poles will reverse. That's why we have increased strength but reverse direction at P. This we have done before in the light section, but we can look at it again. How far from the patient is the image of the chart? So don't think about the patient. Think about the mirror and the image. They are at 5 meter distance. The image should also be 5 meter away from the mirror. So 5 meter this side and 2 meter this. The image is 7 meters away from the patient. So D is the choice. We have done this again. Previously, sorry. 36. The steel rod will be magnetized if one end of a permanent magnet at least repels the rod. Because it's a steel, it should make it a permanent magnet. It's an obvious choice, so no need to worry about the other ones. 37. If an end X of a metal rod attracts N pole of the compass, it could be made of steel, but it's not permanently magnetized. Why? Because it says it could be, because end X might be a temporary magnet, permanent magnet, but it is not permanently magnetized. That's strange. Let's look at the other options. Like I told you, if we are confused about the choices, we use the elimination method. So here we're not sure if it's going to be C or not, let's say. So let's see why A is not possible. It could be made of copper. No, reject the copper ones because they won't be attracted. Okay, the last one left, it could be made of steel with an N pole at X. So N pole at X means N pole for compass needle won't attract X. See how easy it is to reject the choices. C is left. So we have the closest match. It could be made of steel. Yes, it could be, but is not permanently magnetized. So that means the steel we are using is not a permanent magnet, but it is a magnetic material. So that's why it is attracted by the compass. 38. 4 substances are tested from this core. The number of clips is recorded. Which is the best for making core of a transformer? Something that attracts when the switch is on and drops completely when switch is off, which is the only choice here. 6. It could be 4, but we want to make it a good magnet, strong magnet. That's why we have to use C. 39, when we break a magnet, it becomes every piece becomes a complete magnet. And how it becomes a magnet is that the opposite poles are induced in the broken parts. So when X will be a magnet, it will have N pole and S here, N and S here, N and S here. This is how it's going to be. So C, D is the correct choice. 40. So we have this arrangement. Which line gives the best materials for these three places and what we're looking for? Read the question carefully. These type of questions require intuition. M is core of the magnet. L is part of the armature. This is an armature. And S is a stud which stops the armature being attracted too strongly. So M should be iron, so we can magnetize, demagnetize. L should also be iron, so it demagnetizes well quickly. And S should be copper. It shouldn't be a magnetic material, but it will allow the magnet lines, magnetic flux to go through it and attract L. That's why. Now, why all three are not irons? Because if all three are irons, M will attract this, and well, this is a tricky question because S can possibly be iron, but the requirement here is it's too strongly, shouldn't be attracted too strongly. If we make S with iron, the attraction will be enormous. So that's why we should use something that will stop L becoming a strong magnet, very strong magnet. That's why we're using copper here. Number 41, metal bar is a permanent magnet, again, if it repels other magnets.